guys, it's me ActiveXSploit back again with a new video, and hope you guys are doing great. In today's video, we're going to be talking about access token manipulation. So before we start, make sure to leave a like and subscribe to the channel to stay updated with similar cybersecurity content on the channel. So with that being said, let's get started. So what is access token manipulation? So access token manipulation is a privilege escalation attack which is very much similar to token impersonation. So if you know token impersonation, in that attack what we do is we take advantage of the SE impersonate privilege which is present on Windows, and using that privilege we escalate our privileges from a low level user to a high level user. Okay, now in access token manipulation what we do is we take advantage of a privilege known as SE debug privilege, and then uh, using that privilege, okay, we escalate our privileges by stealing a primary token of a privileged remote process running on the local system. So basically what we do is we steal a token of a remote process, and that remote process basically is a privileged remote process. Okay, so it has a high level token, or we could say a privileged token, and then we duplicate that token, and using it we start a new process, and that process could be anything. It could be a simple command prompt or a reverse shell binary which is going to grant us full privileged access. Now as I said, although to achieve this the current user should have the SE debug privilege enabled. Okay, if it is disabled we can enable it by using specific WinAPI functions which I'll be showing you as we go ahead. Now, generally, this trick is actually used to, escalate from a local administrator user to anti-authority system. But let's say that if you compromise a standard user on the system, and if that user has the SE debug privilege enabled, then you could try this trick to escalate from that standard user to anti-authority system. But also, in today's scenario, we are going to escalate from a local administrator user to anti-authority system. Uh, now, okay, so here's a little meme for you guys. Now, I did explain you what is access token manipulation, but you guys don't know what an access token is. So obviously, guys, you don't have to worry. I'll explain you what an access token is, from where does it come, and what information does it contain. So, what exactly is an access token? So, an access token on Windows is an object which specifies security context of a process or a thread. Okay. Now, let's actually imagine a scenario. So, let's say that you log on to your system. Okay. You start up your computer, and you enter your username, and then you enter the password. Now, after successful authentication, your system is going to generate an access token which contains specific information such as SID of your account, a logon SID, source of the access token, etc. Now, as you log in, okay, as you let's say that you finally have an access token and you finally log in, and then let's say that you execute Google Chrome or you execute any other normal process. Okay, so that process, which is executed on the behalf of the user, has a copy of this access token. So whatever process you execute is going to have a copy of the access token which your system generated when you logged in. Okay. Now, there are two types of access tokens. So one is the primary token, and the another one is the impersonation token. So primary token is basically a token which is created by the Windows kernel, and it is assigned to a process to represent the default security information for that process, as I said previously. And then we have the impersonation token. So impersonation token, on the other hand, is a token which captures the security information of a client process, allowing a server to impersonate the client process in security operations. Now, if you want to, dive deeper into access tokens, I'll mention some links in the description below, and you can refer from there. So that's all for the theory part. But before getting started off by the coding part, I wanted to explain you guys the code first, because like it is kind of complicated for you if you are learning it for the first time, because me myself found it very much complicated when I learned this technique for the first time. So what I'll do is I'll break down the code in a few blobs, okay, in small blobs, and I'll explain you guys first, and then we'll get started off by the practical coding part. So first we start out by declaring the necessary header files, which is the windows.h, and then we have standard input output, and we also link up a library called advapi32.lib, and then we declare a function called void enable privileges, and this particular function takes three arguments. So we have the token handle, and we have a string which basically specifies the privilege constant or the privilege name, and then we have a boolean value whether to enable or not to enable that privilege. Okay. Now then we declare the token privileges structure, which is like important. It is important because we want to enable that privilege, and then we have the a pointer. We have a pointer called LUID, and that pointer is basically to receive the LUID of the privilege on the local system. And then we have a function called lookup privilege value. So lookup privilege value is going to look up for the LUID of the privilege which we specify, and then it is going to store that particular LUID in the pointer which we have specified over here, which is LUID this one. Okay. And then we have a small blob over here, which is this blob, and this small code blob, it's actually doing nothing much, but we basically set some parameters to actually enable the privilege. Okay. And as I said, we have the adjust token privileges function, which basically sets privilege or for a specific token. So it is going to enable the se debug privilege in our case for our token. Okay. And then just a minute. And then we have another function, which is the main function. Now in the main function, first of all, let's talk about this blob over here, this code blob. So now we have the main function. So in the main function, first of all, we have the value of the process ID which we want to impersonate, and in our case, it's going to be the winlogon.exe process. I'll show you what exactly it is as we move ahead. And then we declare a few handles. So first handle is the token handle one, which is a handle to store the remote process token. And then we have the duplicate token handle, which is basically the handle to store the duplicated remote process token. And then we declare two structures. So first one is the startup info structure, and then we have the process information structure. So these two structures are actually necessary, and you'll know why as we move ahead in the code. Uh, and then we initialize those structures by removing the memory inside them, removing any sorts of space inside them. If you actually look up on the Microsoft documentation uh, for these two structures, you'll know why we perform the zero memory function on them. Okay. Now then we have the then we have this another code blob over here. Just a minute, guys. And in this code blob, we are declaring a current token handle. So this current token handle is basically a handle to get the current process token. Okay. So then we use the open process token function to get the token of the current process. As you can see, I have specified the handle of the current process in this case, and it is going to store the current process handle into this point over here, or into this handle over here. Okay. And then just a minute. And then we use the enable privileges function, which we declared previously in our code, to enable the se debug privilege. And as you can see, we have specified three arguments over here. The first one is the current process token handle, and then we have the se debug name. Now se debug name is basically a privilege constant, and in simple language it means se debug privilege. Okay. But in the code we have to specify its privilege constant. Okay. If you want to know other privilege constants, you could always refer to Google, or you could always go to Microsoft documentation, and you'll find the list over there. And then we set the boolean value to true, so that we are enabling that particular privilege. If we set this to false, we are going to disable that privilege. Okay. And then we Yeah. So and then we retrieve a handle to the target process, okay, and then we steal its token. So first of all, we use the open process function to retrieve a handle to the target process, and then we use the open process token function to steal the process's token, okay, that particular process's token. And if you notice, in this case, we have specified the PID of the remote process of whose token which we want to steal, okay. Then what we do is we impersonate the current user's token with the token which we just stole using the impersonate locked on user function. After we impersonate the current user's token, we use the duplicate token X function to duplicate the stolen token, and we store that stolen token in the handle which we specified previously, and that handle is duplicate token handle, okay. And then we finally create a process with that token. So we basically create a new process with the stolen token which is stored over here in the duplicate token handle. So we use the create process with token w function, where we specify the token handle which is the duplicated token, and we specify the path of the process which we want to create, which is going to be cmd.exe in our case. And we also specify pointers to the startup infrastructure and the process information structure which we declared previously. So that's all for the theory part. Now we'll get started off by the coding part. So I'll see you over there. Okay, so firstly, we start out by declaring the necessary header files. So first we have the windows.h header file, we have the standard input output header file, and we also have to link the adwapi32.lib library. So I'll just link that up. Now, after declaring the necessary header files, we create a new function called enable privileges. Whoops, sorry for that. And in this function, we specify three arguments. So first of all, we have the h token argument, and then we have the privilege string, and then we have the boolean value, whether to enable the privilege or to disable it. And then we create a new structure. We declare a new structure called token underscore privileges, and we set its name to TP. And then we declare a LUID pointer to store the privilege LUID value in. And then we use the lookup privilege value function to retrieve the LUID value of that privilege and store it in our LUID pointer. So I'll just say null lps set privilege LUID, and then we set some parameters to actually enable that privilege. So first of all, we have the tp.privilege count. We set it to 1, and then we set the tp.privileges.luid to the LUID pointer which we declared, and then we enable the privilege. So we basically set the attribute to AC underscore privilege enabled. So we say tp.privileges dot attributes is equals to SE underscore privilege underscore enabled. Okay. And then we use the adjust token privileges function. So I'll just say adjust token privileges, where we specify the h token as the token handle over here, and then we specify a false. We specify the token privileges structure, a pointer to the token privileges structure, and we specify the size of the token underscore privileges structure, and we set the p token underscore privileges value to null, and we also set the value of pdword to null. Okay. And then we declare the main function, so I'll say int main. And first of all, we declare the PID of the process to impersonate. Okay, so I'll just say int PID to impersonate is equals to, and I'll leave this as blank for now. Once we compile our program, I'll change it to the process ID of winlogon.exe process. Okay, and then we specify the handle of the token, so I'll just set this to null for now. And we also specify the handle of the duplicate token handle, so I'll just say duplicate token handle, which is equals to null. And then we specify the startup info structure, and we also specify the process information structure, and we initialize the structure as mentioned on Microsoft documentation, so I'll just say 0 memory. Oops, startup info 0 memory process information size of process underscore information, and I'll initialize it lastly startup info.cb is equals to size of startup info. Then now we start the process of retrieving the current process token, so we'll declare a new handle called current token handle, and I'll set it to null. And then we use the open process token function to retrieve the process token. So what I'll do is I'll just say bool get current token is equals to open process token get current process, as we want to get the token of the current process. So we specify a handle to the current process, and the desired access, I'll specify it as token adjust privileges, and I specify the pointer to the current token handle, so current token handle. And then we finally enable the privileges, so we say enable privileges. Enable privileges is the function which we previously defined, so yep, I'll just say enable privileges, and I'll specify the current token handle and the privilege constant for SE-debug privilege, and I'll set this value to true. And then finally we retrieve a handle to the target process, and we're going to steal its token. So for that, what I'll do is I'll declare a new handle called rproc, and I'll say rproc is equals to open process. We use the open process function to retrieve a handle to the target process first. So process underscore query information is the desired access which we want, and we are going to inherit the handle, and the process ID is going to be the PID to impersonate variable. And just a minute, I'll actually set this up well. Yep, then we get the token of this remote process. Okay, so we steal its token. So for that, what I'll say is I'll say bool r token is equals to open process token, where we specify the handle of the target process, which is rproc in our case, and the desired access is going to be token underscore duplicate token underscore assign primary and token underscore query, and we specify the token handle where we want to store this particular token, a pointer to that token handle to be more specific, which is going to be token handle. And then we use the impersonate logged on user function to impersonate the current user's token. So I'll just say bool impersonate user is equals to impersonate logged on user, where we specify the token handle, and then we use the duplicate token x function to duplicate the stolen token. Okay, so I'll just say duplicate token x, where we specify the source token, the existing token, which is token handle, and we specify the desired access, which is going to be token all access, and we set the LP security attributes to null, and we specify the impersonation level as security impersonation, and the token type is going to be primary token, so I'll just say token primary, and we specify a pointer to the handle where we want to store our duplicated token, so I'll just say duplicate token handle. And now we finally use the create process with token w function to create a process using the stolen token. Okay, so I'll just say create process with token w, where the token is going to be the duplicate token handle, and the logon flags, for the logon flags part we specify logon with profile, and then we specify the path of the process which we want to execute. So in this case, in this scenario, we are going to execute a simple command prompt, so I'll just specify the path to it. We'll see Windows system 32 cmd.exe, and then we specify the lp command line to null, and the creation flags as 0, lp void lp environment to null, and the lp current directory also as null, and then we specify the pointer to the startup info structure, which is going to be startup info and process information, and finally we return 0 at the end of the function. And let's check for any errors or any other stuff. Let's check if the code is correct and there are no syntax errors or anything like that. Okay, just a minute. Oh, there's actually a spelling mistake over here, sorry for that. And we have to specify one more backslash over here, so just a minute. Let's check whether everything else is correct. Okay, so everything else seems to be working and it is correct. So now that's all for the coding part. What I'll do is I'll compile this code and I'll move it to my Windows VM and we'll test it out over there. Okay, so here I am with my Windows 10 virtual machine, and I have my access token manipulation privilege escalation exploit compiled up over here. And the process which we are going to target is the winlogon.exe process, and as you can see, the PID of the process is 460 over here. So I've also changed it in the main code, which is 460 over here, and after changing it I have compiled it. So for proof, let me actually compile it in front of you guys. So I'll just say cl.exe/tc, and there we go. As you can see, we have the output over here, which is atmv.exe. If I go back to my Windows virtual machine and refresh this up, I'll move this binary to my desktop, and now I have a user over here, which is this one, the test user, and this test user is a local administrator on the system. So if I actually run who am I, as you can see, we have test over here as the username, and if I run who am I/priv, as you can see, I have the SE debug privilege, and also I have all of these privileges as I'm the local administrator. I'm not anti-authority system yet. Okay, as you can see, when I run who am I don't get anti-authority system over here. all I get is test as the username, and that is because I am the local administrator over here. And to escalate my privileges from a local administrator to into authority system, we can utilize the AC debug privilege over here to to escalate our privileges by stealing a token and creating a process from that token. Okay, so now what I'll do is I'll run up my access token manipulation binary. So I'll just say access token manipulation v.exe, and there we go. As you can see, we have a another command prompt popped up on our screen. And if we run who am I, as you can see, now I am anti-authority system. And if I run who am I slash priv, obviously we're going to have all of the privileges. As you can guys see, we were able to escalate our privileges from a local administrator to anti-authority system by access token manipulation. And if you want to try this out in your own lab, I'll drop down a link in the description to the code file which you can compile on your own and test it out in your lab. So that's all guys for today's video. I hope you enjoyed it. Make sure to leave a like and subscribe to my channel. Bye bye and have a good day.